Hello, astronomy class. So I'm here to give you an introduction to this week's observation and what I want you guys to do. So last time you guys did an observation of the sky, you guys chose an object. A lot of you guys chose the moon, and that's great. That's a great target to pick. I had you guys measure the elevation, or excuse me, the altitude. They're both the same thing. I should say altitude, since that's what stellarium says. How did you guys measure the altitude of your object? That's the height above the horizon. And so as you can see my simulation here, I'm using a star. I can move the star to show how the altitude changes and how you measure that degree marking. And I haven't last time even went over some hand gestures you could use if you're outside to measure the altitude yourself. This time I'm going to have you guys measure one more marking. In addition to altitude, I'm going to have you guys measure azimuth. So azimuth is basically measures how far north, east, west, or south something is. So as you can see, I can move my azimuth direction all the way around and back to the beginning. So whereas azimuth, I said went from 0 to 90 because 90 is the top of the sky. And actually, some of you guys reported below 90. This simulation won't let me do it, but I can go below the horizon to get, I could technically goes from 90 to negative 90. So azimuth goes around full circle. If you guys remember from last week, there's 360 degrees in a circle. So north is both 0 degrees and 360. If I try to go all the way to north, it will go to 359 and then reset at 0. So north will always be 0 degrees. If I go to, but let me move it. Just trying to move the azimuth. There we go. East will be 90. South will be, come on. Should make that guy happy. South will be 180. West will be 270. I don't expect you guys to memorize that. If you look in the observation guidelines, I updated it for this week. And there's some hints on how to find your azimuth. So here's a little chart. If you know where north is, you know you're facing at 0 degrees. But whatever your object you pick probably won't be at 0 unless you pick a special star in the night sky. And I'll let you guys find out where the North Star is. There we go. I'm trying to draw here. So 0 degrees is north, 90 east, 180 is south, 270 is west. But let's say you have an object that's like northeast. Well, if you found something that's about between north and east, that would be 45. If you find something between south and west, like southwest, that would be 225. So use this little compass and this chart to help you find your azimuth. Keep watching this video to the end though, because I'm going to show you guys some more hints on how to find the azimuth. And let me kind of pause my recording real quick. All right, so let me kind of give you some ways that you can measure azimuth if you're outside in the open. So let's say that where I'm facing you right now, that's north, which means that if I spread my arms out all the way, that to the board here would be south, okay? So north, south, and then if I want to find east, I just clap my hands in the middle, there's east. I could go the other way around too. If north is on my right, south is on my left, clap my hands the other way, that's west. Now stars, the moon, and the sun won't always be in those 4 cardinal directions. So let's say that I have north here, and then I make a 90-degree angle, so I kind of make a box with my body, and put my body in the middle of the box, clap my hands, that's northeast. I do the same over here, east, south, put my body in the middle, clap, there's southwest. So when you guys find your azimuth this week, I don't expect you guys to get too fine, but remember, you're reporting not the direction, you're reporting the angle or the azimuth degree. So use that chart, north being 0, northeast 45, east 90, et cetera, use that chart to report the actual azimuth degree. Another thing that you could do is you could download an app that has a compass on it, or you can actually just look for a compass app. The one I use here is called Physics Toolbox Center Suite. Excuse my desktop of the beach here. Here's you can see this is what Physics Toolbox looks like in the App Store, but really any compass app. Let me show you what this one looks like. So if I am using the Physics Toolbox app, I can go to the menu here on the left side. You would have to scroll down a little bit to find magnetism. But once you do, there's a compass is the first option. So let me get my hand, let me get this out. So here's my compass right here. If you're using a compass on a phone, you might have to kind of wave your phone around a little bit to make sure it gets the right directions. Well, let's see, I think I get it to face north. Yep, there's north right there. As I turn my phone, it will tell me the approximate azimuth angle facing the computer screen right now. It says 97 degrees east. So now that 96 or 97 degrees, well, now it's changing a little bit more. You have to kind of estimate there. So maybe 94 degrees, that would be my azimuth. So as I'm looking at you, you are at 95 or 94 degrees. So you can use an app. If you have a real compass with those markings, that would actually help too. Let me show you one more way you can find your azimuth. Close this. So one way is just to use stellarium. I've been saying that you guys don't have to actually do an observation outside. If you can't get outside for whatever reason, whether it's work or weather, I know it's going to be really cold this week, so you can do your observation indoor by just using stellarium. And what you can't really use your hands or your body to measure azimuth and altitude, but it gives you those readings all by itself. So for example, here I am in the daytime. If I click on the sun, like maybe I want to do the sun for this week's observation, where it says as out down here, here's my azimuth and altitude marking. So the sun, let's see, the time is 11:51 in the morning, and it is January 25th, 2022. And right now in my location, the sun has an azimuth of 173 degrees, which is almost south, and 32-degree altitude. So it's not even halfway up in the sky. It's going to be lower in the winter. So there you go. Stellarium is how I grade your observations. When you guys have been sending me the observations, you gave me the altitude last week. This is how I graded it. I put in the time and the date that you said you observed whatever object it was, and then I made sure your altitude measurement lined up. So if you do this week's observation by yourself, and you're doing this outside and you're not sure about your azimuth and altitude, well, just check it on stellarium before you turn it in to make sure you got the right azimuth and altitude markings. Definitely use your body if you can, but if you can't, use stellarium to help you find those the azimuth and the altitude. It's the as out line there. If you're using an app, just make sure you look for azimuth, altitude, or it might say something like azimuth or an elevation. So that's all I have for you right now. Hope this week's observation goes well. If it is cold outside, don't feel like I'm forcing you to go outside to make your observation. As always, at the bottom of the observation guidelines, there's a list of astronomical events. Let me just kind of give you guys some highlight before I sign off. Let's see, January 21st, 25th is the third quarter moon, which means it should be like half full in the sky if you get to see it. Third quarter moon means it will be rising around midnight. No, excuse me. Yeah, that's right. Rising around midnight and setting around the times, or no, I can't remember where it says. Anyway, some other events going on this week. There's a star that's going to be, Pollux is a bright star. It's going to be 3 degrees away from the moon. So that'd be a pretty cool conjunction to look at. Anyway, so if you guys have any questions, please send them my way. I hope this video was helpful to you. Talk to you later. Bye.